Hey there, science fans! Welcome to another exciting journey into the world of mathematics. Today, we're diving into the fascinating and dynamic world of functions. Functions are one of the most fundamental concepts in mathematics, and they play a crucial role in everything from basic arithmetic to advanced calculus. Imagine a magical machine, a function machine. This machine is not just any ordinary machine, it's a special one that can transform numbers in amazing ways. It's like a toy maker, but for numbers. Just as a toy maker crafts toys from raw materials, a function machine takes numbers and transforms them according to specific rules. You put a number into the machine. This number is known as the input. This is called the input. The input is the starting point, the raw material that the function machine will work its magic on. The machine uses its special rules, like adding or multiplying. These rules are the heart of the function machine, determining how the input is transformed. Then voila! It spits out a new number, the output. The output is the result of the function machine's transformation. Every function machine has its own set of rules. These rules can vary widely, making each function unique and interesting. It tells the machine what to do with the input. The instructions are like a recipe, guiding the machine step by step. For example, one machine might double the number you put in. Another might add 5. These are simple examples, but functions can be much more complex. It's like magic, but it's really math. The beauty of functions lies in their ability to make complex transformations seem almost magical. Functions are the cool tools mathematicians use to describe how numbers change and relate to each other. They help us understand patterns, make predictions, and solve problems. Ready to learn more? Let's go! Join us as we explore the wonders of functions and discover how they shape the world of mathematics. Remember our function machine? The number you put in is called the input. It's like the ingredient in a recipe. The output is the result you get after the function machine works its magic. It's like the delicious cookie you bake. Let's say your function machine adds 3 to any input. If you put in 5, the output will be 8. Input 5, output 8. Every input leads to a specific output. It's like a cause and effect relationship. You put something in and something specific comes out, based on the function's rule. Every function has a domain and a range. Think of them as the function's playground. The domain is like the allowed inputs. It's the set of all numbers that can go into the function machine. The range is the set of all possible outputs. It's like all the different results the machine can produce. For example, imagine a machine that only accepts even numbers. Its domain is all even numbers. If it doubles those numbers, its range would be all even numbers too. Domain and range help us understand the limits and possibilities of each function. Mathematicians have a special way of writing functions, like a secret code. This code helps them communicate complex ideas in a simple and efficient manner. It looks like this: fos x equals sign. This notation might seem mysterious at first, but it's actually quite straightforward once you get the hang of it. Don't worry, it's not as complicated as it seems. With a little practice, you'll be able to read and write these functions with ease. The F just stands for function. Think of it as a machine that takes an input, does something to it, and gives an output. The X tells us that X is our input. It's the value we feed into our function machine. The after the equal sign is where the function's rule goes. This rule tells us what the function does to the input. For example, if the rule is to add 3, it would look like this: fx equals sign x plus 3. This means our function takes any number x and adds 3 to it. So f5 equals sign 8 means that when we put 5 into our function f, the output is 8. This is because 5 plus 3 equals 8. It's a shorthand way to write it all down. Instead of writing out the entire process every time, we use this notation to save time and space. Once you understand the basics, you'll see how powerful and useful this secret code can be in solving math problems efficiently. Section 5. Tables. Organizing the function's secrets. We can organize a function's inputs and outputs in a neat table. It's like a secret codebook for the function. One column is for the input x, The other column is for the output, fx. Each row shows a pair of input and output values. For example, our function fx equals x plus 3 could be represented in a table like this. xfx 142536. Tables help us see the relationship between inputs and outputs clearly. It's like having a cheat sheet for the function. Section 6, Finding Secrets with Formulas, Input, and Output Detectives. Welcome to the world of mathematical mysteries, where we become detectives to uncover hidden secrets using formulas. Sometimes we have the function's formula and need to find the output for a specific input. Imagine you have a mysterious function, and your job is to discover what it produces when you give it a certain number. It's like being a detective. Just as a detective pieces together clues to solve a case, we piece together numbers and operations to solve mathematical problems. Let's say our formula is fx equals 2x plus 1. This formula is our key to unlocking the mystery. We want to find f of 3. This means we need to determine what the function produces when we input the number 3. We simply replace the x in the formula with 3 and solve it. By substituting 3 for x, we follow the steps to uncover the result. So f of 3 equals 2 times 3 plus 1, which equals 7. Step by step, we see how the numbers interact to give us the final answer. We found the secret output. The number 7 is our hidden treasure, revealed through careful calculation. We can also work backward. Sometimes we know the output and need to figure out what input produced it. If we know the output and the formula, we can find the input. This reverse process is like retracing our steps to find where we started. It's like solving a puzzle. Each piece of information fits together to reveal the bigger picture, whether we're moving forward or backward through the problem. So, whether you're finding outputs or inputs, remember that you're a detective on a mission, using your skills to uncover the secrets hidden within the formulas. Keep solving and enjoy the thrill of discovery. Section 7, Graphs. A picture is worth 1,000 numbers. We can also visualize functions with graphs. Remember those x and y axes on a grid? We can plot the input on the x-axis and the output on the y-axis. Each point on the graph represents an input-output pair. Connecting these points gives us a line or curve that represents the entire function. Graphs help us see the overall behavior of a function. Is it increasing? Decreasing? It's all there in the picture. Section 8. The vertical line test. A function or not? Not every graph represents a function. Remember, a function can only have one output for each input. To test if a graph is a function, we use the vertical line test. Imagine drawing vertical lines through the graph. If any vertical line intersects the graph at more than one point, it's not a function. This means one input has multiple outputs, which breaks the function rule. Section 9, one-to-one functions. Each input, a unique output. Some functions are special, they're called one-to-one functions. In these functions, each input has a unique output. No sharing allowed. Think of it like a secret code where each letter has only one symbol. It makes decoding much easier. One-to-one functions are important in math. They help us reverse the function process and find the input when we know the output. Section 10. Why functions matter, real-world wonders. Functions might seem like a mathematical game, but they're everywhere in the real world. Scientists use functions to model how things change over time, like the growth of a plant or the speed of a rocket. Engineers use functions to design bridges, buildings, and even roller coasters. Functions are the hidden language of the universe, helping us understand and predict how things work. Section 11. Keep exploring. The function adventure continues. Congratulations, explorers! You've journeyed into the world of functions and discovered their secrets. But this is just the beginning. There's so much more to learn about functions, from different types to their amazing properties. So keep asking questions, keep exploring, and keep the fun alive in math. Because the world of functions is full of exciting discoveries.